So we're going to talk about some vector definitions, what vectors are, and some things related to that. Vector definitions. So to get us started, so what a vector is, it's something that measures the magnitude and direction. It's a measures the length, magnitude, and a lot of times we denote this with an R. So measures the length and direction. And for direction, sometimes we use theta or just an A for the angle. So we're talking about the angle that the vector is moving. So it's used for things like force and velocity, electric current, things like that. And so it's represented with arrows. Okay, so it's used in in physics and a lot of related classes talking about force or acceleration or current. The standard position of a vector, standard position, is when we place the vector, on a coordinate system. Place the vector on a coordinate system, and it starts at 0. Starts at 0, 0, so at the origin. And then it goes in the direction of starting on the positive x-axis. So for this, I'm gonna show on the coordinate system. So here's my coordinate system. So if I have a vector, the direction is measured by starting right here is 0 degrees and then moving in the counterclockwise direction from there. This would be a positive angle. Positive angle, positive theta. I'm using theta to represent angle. If I were moving in a negative direction, I'm going clockwise from the positive x-axis. So kind of to put some reference to this, let's go around positive first. So if I start to the right, x-axis positive, straight to the right, that is 0 degrees. If I go from there, the vertical going up is 90 degrees because this makes a right angle. And then if I keep going around in this direction, the straight line that's made going to the left, the negative x-axis is 180. If I keep going, 180 and another 90 is 270. And then keep going to finish up the circle, I'm at 360. And I can keep going if I add another 90, I'm back up straight, add another 90. I can keep going around multiple times. But these are kind of our main references between 0 and 360 for one full rotation. Now if I go in the negative direction, so starting at 0, if I go down the negative y-axis, this is going to be a negative 90 degrees. So 270 and negative 90, those are equivalent on the coordinate system for angles. So then if I continue around, 180 and negative 180 are the same. Continue around, 90 is the same as negative 270 degrees, and keep going. To make a full rotation in the negative direction, I would have negative 360. So this is kind of our reference points. Now, the next thing we're going to talk about, and I'm going to make it so we can still see that, we are going to kind of use this coordinate plane we just did and define what a related angle is. Related angle, or sometimes it's called reference angle. These mean the same thing. Related angle or reference angle. So what this is the acute angle formed by a vector and the x-axis. Between a vector and the x-axis. So some keywords here. Acute. When we talk about an acute angle, make a little reminder that an acute angle is an angle between 0 and 90 degrees. Between 0 and 90 degrees. 0 degrees and 90 degrees. So that's what an acute angle is. And the key here is to keep in mind we're talking about between the vector and the x-axis. So we're always going to the x-axis, not the y. So let's say, for example, I want to find the related angle. Find the related angle for 150 degrees. So 150 degrees, I'm going to sketch this out, would be in quadrant 2 because it's between 90 and 180. So maybe about here. So the related angle is the acute angle formed by the vector and the x-axis. So here's the vector, here's the x-axis. So the angle made between those, if 150 is right here, and then 180 is the straight line, we're looking for the difference of those. So 180 minus 150 will get me 30 degrees. Okay. Or how about find the related angle for 238 degrees. So 238, this is somewhere in quadrant 3. So if we're kind of counting around 1, 2, 3, and 4. So somewhere in quadrant 3, so because we're past 180, we're not to 270. So we're somewhere between those. So if 238 is right here, again, we're doing the difference between 238 and 180 because it's always to the x-axis. This time in this quadrant, though, I would always be doing the angle minus 180 instead of in quadrant 2, 180 minus the angle. So I get 58 degrees. So this angle between the x-axis and the vector is 58 degrees. How about find the related angle for 348 degrees. So I'm in quadrant 4, almost to 360 it looks like. Here's my vector. Here's 360, here's 348. So the difference between those, 360 minus 348, is going to be 12 degrees. Okay, so that would be the related angle. So we just did an example in quadrant 2, 3, and 4. I skipped quadrant 1 because quadrant 1 is a little different. Let's say I want to find the related angle for 20 degrees. Okay, so in quadrant 1, here's 20 degrees between 0 and 20. Well, it's just going to be 20. So when you're in quadrant 1, it's already between 0 and 90, so I don't have to do anything. Okay, so the other way we can look at this, let's do just one more example. So kind of similarly, but going the other way. For the related angle (40 degrees) in quadrant 2, find the direction. Find the direction. So now I'm being told that my related angle is 40 degrees in quadrant 2. So I'm in quadrant 2, 40 degrees from the x-axis. So right here is 40. So from 180 going back 40, I would figure out that this is 140 degrees. Okay, not the only way to do it, but probably the quickest way. Let's do one of those. How about this one? For the related angle 75 degrees in quadrant 3. Find the direction. So the full direction. So 75 in quadrant 3. So 75 as the related angle is between the x-axis and the vector. So if right here is 75, from 0, I'd be 180 and another 75. So that leaves me with 255 degrees.